Hello everyone. Oh, hello everyone. Hi everyone. So this is your EE211 Moodle page. First of all, you will go here in lab work. I have uploaded the slides for lab number 1. You can download it from here, and then because this has all the formulas, you will need them in your first lab. Then here there is a link for Multisim Online. You will click it. And then from here you can go to online multisim. Okay, so you have to log in, then you will go here and then you will click on create circuit. Okay, so in this lab the primary purpose is to learn about the RMS and instantaneous values of current and voltage. I is for current, V for voltage, then average real power, reactive power and complex power. And then impedance Z is equals to R plus JX. Okay, X can be the reactance due to a capacitor, and it can be reactance due to an inductor. Okay, for inductor this is J omega L. For capacitor it is minus J by omega C, and omega equals to 2 pi F. Okay. Then average power, reactive power and complex power, we have the formulas. Average power is denoted by P, reactive power is denoted by Q, and complex power is denoted by S. Okay. So this I just explained you that omega equals to 2 pi F. 2 pi F, and F is equals to 1 by T. Okay. Then this is the formula for the real power. Then for reactive power, the denoted by Q, and the formula is Vp IP. This is I divided by 2 into sine of theta V minus theta I. Okay. Then complex power is S is equals to this is P, this is Q, and S is equals to P plus JQ. Okay. Yeah, it's here. Then we have apparent power, which is only the magnitude, this thing. Okay. Yes. So let's start the experiment. This is your lab sheet. Okay. So we have 3 different circuits here. First one is the resistor circuit. Next is inductor, and the third is capacitor. Okay. So let's make this circuit. I will make it smaller so that it will be easy for me to look at it. Okay, so here we will create our circuit. First step is to save your circuit. Okay, so lab 1 resistor. First is the resistor circuit. We will save it. Okay, then I need AC source. I will get it from here. Then I need resistor. Then I'm looking it from here. Okay, 3 resistors. Okay, I can just copy this resistor here. Then I can copy it here. This I will rotate it from here. Okay, then just make the connections. I need one ground. Okay, click on this component, and from here we can rename it V input, and the value is here 5 volt and 1000 hertz. Okay, right here 5 and 1000, it's already 1K, so this is 1000. This resistor is 1K, this is also 1K, and this one is 2.2K. We will click on it and write here 2.2K. Okay, then we need voltage probe, and then this we are connecting it at the input, so this is input, so we will write it here, we input. Then I need another voltage probe, this is output. Okay, so I will connect it here, and then I will write its name as Vout. Okay, then the third one I will connect it here, this is for the current. Okay, I will write the name I out. Okay, then run it from here and go to grapher, right? You will get this grapher. Okay, then okay, we have V input, green is V input, blue is V output, and dotted is I output. Okay, for the moment I don't need this I output. I'm interested in the output peak voltage. Just put your cursor, it's easy, like you will just put it on any peak. For example, this is 2.615. You will go down, and one thing here, as the frequency is 1000, so time period is how much? Frequency, time period T equals to 1 by, just a minute, T is equals to 1 by F. Okay, we have 1000 time, so it will be 1 into 10 to the power minus 3 second. Okay, so you will write here 1 millisecond, and you will put here M, millisecond. Okay, then peak value of voltage is how much? 2.615. Write it here, 2.615. This is volt, so unit is volt. Then the next step is to check this, and let's make it more clear. So now this is 1.1887. So this is 1.1887 milliampere. It's milli, so you will write it here milli. Okay, then third step is to find theta out minus theta input. Okay, so we need input and output voltage, and we don't need current. Then you will just choose cursor x-axis. Okay, x-axis first will be V input and then second will be V output. Okay, so move it to the 0 cross. So 0 is here. Okay, this is 0. You can zoom it by scrolling, and it will zoom. So look, this is 0. So you will place it at 0. Okay, first cursor at 0. Then you will bring another cursor also at the same 0 crossing. Okay, now look, this is 0. It means that the phase difference between input and output is 0. Why? Because this is resistor. In resistor, there is no phase difference. Okay, voltage and current are in phase, input and output is in phase. Now then I will go here, power. Okay, for power I have formula here, real power. Okay, this formula. Okay, control C, and I will put it here. Okay, now take your calculator and put the values here. So I want to bring, okay, so I have formula Vp Ip divided by 2. So Vp is this, Ip is this. So 2.615 multiplied by 1.1887, it's milli. So multiply by 10 to the power minus 3 divided by 2, and then cosine of 0 because your angle was 0. Okay, just calculate it and you will get calculate it on calculator. So 2.615 multiplied by 1.1887 milli divided by 2 cosine of 0, it is 1.554 milli. So you can write it milli here, milliwatt. Okay, then similarly the formula for complex power is, for the reactive power is this one. Q is equals to Vp, same thing but with sign. Okay, the difference is only sign. Here we have cosine. So same 2.615 multiplied by 1.187. So this is Vp. So this is Vp. This is Ip. Okay, and instead of this there will be sign. Okay, so sine of 0, it will be 0. Okay, in case of resistor there is no reactive power. Then complex power, S is equals to P plus JQ. It's capital S equals to P. P is here 1.554 plus 0J. Okay, then impedance. So for the impedance we have formula, as we don't have any reactance like capacitor and inductor. So Z will be, you will go back to your circuit, add these three resistors 1K, 1K and 2.2K. It will be 2 plus 1 plus 1, 4.2K. Okay, it will be square root of 4.2 square. So square will cancel with this, so it will be 4.2K. Okay, finish for this one. So we will put it 4.2 and we can write it here kilo, or you can write it here, it's up to you. Okay, now this is for the first. Then you will need screenshots for, and here you have to put your name. You will put your name from here. You will go here, then ABC text, and then you can put your name and ID. Okay, you will take screenshot of the circuit. Then for the grapher you will make 3 screenshots. One is for the peak voltage, the other is for the peak current, and the third one is for the phase. Okay, all these here I need screenshots. Okay, and one circuit. And now let's go to the second one. The second circuit is with inductor. Okay, 100 millihenry. What I will do is just remove this one and bring inductor from here. Okay, you will, okay, the inductor value is 100 milli. Okay, the rest of the things will remain the same. Let's again one, yes. So let's run it and go to the graph. Okay, now okay, now stop it from here. And the same thing, first of all we have to get the output voltage. Okay, okay, so how much is the output voltage? 3.3614. Okay, you will go here, .36. Okay, this is volts. Then check this current here, and it's okay, 1.5279 milliampere, 1.5279 milli. So it's already milli here. So remember that you have to make all the units correct in order to get full marks. So now, what is the third step? Third step is to get the phase angle. Okay, now uncheck current. Now zoom it, because zoom will be better. Okay, now one cursor at input, 0 crossing, and another cursor, choose V out. Okay, same 0 crossing, so it's here. Now look, there is a phase difference. Okay, now output voltage, as this green one is crossing 0 first, the blue is crossing 0 second later, so it means that input is leading. Okay, so now let's see what is the delta x here. This is 30.334. For this, I will go here. Okay, so this is how much? 30.334 microsecond. So okay, so for the phase angle, theta will be 30.3433. Micro means 10 to the power minus 6. We'll multiply it with 360 and multiply it with frequency, which is 1000 hertz. So this is basically delta x multiplied by 360 multiplied by frequency. Okay, then calculate this value. So 30.33 micro multiplied by 360 multiplied by 1000. This will be 10.91. Okay, so this will be 10.91. Okay, now you have all these three values. Same steps we will do it here. We will put this peak here in this formula. So Vp is 3.36. 3.36 multiplied by 1.52 into 10 to the power minus 3 divided by 2, and cosine of this angle 10.91. Calculate this value. 3.36 multiplied by 1.52 into 10 to the power minus 3 multiplied by cosine of 10.41. So this will be 2.51 milliwatt. Okay, so milliwatt is here. Then same thing, we instead of cosine we will put here sine. So this will be 4.614. 4.614. Okay, and it will be S is equals to P plus JQ. So 2.51 plus 4J into 4.614. Okay, then okay, for this one we have now X. Okay, which is X L is equals to J omega L. So omega is 2 pi F into L. So 2 pi multiplied by 1000 multiplied by inductance, which is 100 into 10 to the power minus 3. Calculate this. 2 pi multiplied by 1000 multiplied by 100 millihenry. Okay, so this is 628. Okay, so this will be 628. So now z is equal to square root of r square. So r is how much? 1k plus 2.2k. It will be 3.3k. It will be 3.3 meters per 3 square plus this 628 square. How much it will be? Square root of 3.3k square plus 628 square. 3359. Okay, so this will be 3359. Okay. Or you can write it 3.35k, 3.36k. Okay. Then this is done. Then you will take screenshot for circuit and three different screenshots for one for voltage in output voltage, one for output current here, and one for the phase angle. Okay. Similarly, now let's go to the third circuit. We have to use 100 nanofarad capacitor. Okay. You will just replace it and delete this one from here and put here capacitor. Okay. So the value of capacitor is 100 nanofarad. Okay. Change it to 100 nano. N for nano. Okay. Now run it. Now same steps. Close it from here. And for the moment, just remove the excess and then just check. Okay. Now check this. How much? 3.07 volt. 3.07 volt. Sorry, volt is already there. No, it's not here. It should be here. 3.07. Then current. Check it from here. Okay. Then 1.399. 8. Point 3 milliampere, and then theta. Check this and check this one. Zoom it and bring from here cursor. One is V input, one is V output. Okay. So this is input. This is output. Okay. Now you see this is minus 74.9 microsecond. So what you have to do is minus 74.9 micrometers minus 6 multiplied by 360 multiplied by 1000. This will be minus 26.96. Now you have all these three. You can just plug the values here and there. For XC, you will put it here minus j by omega c. XC will be minus j by omega c. Okay. So remember for the inductor, it will be minus here. Okay. And for capacitor, it will be plus. So Omega is equal to 2 pi f, and C is 100 nanofarad. You will put it value and then you will get X. You will put it that here, add resistor, and then you will write value here. Similarly, you will plug values in this formula, these values with this angle, and you will just write here the value of S. Okay. So after when you are done with all of this, you will write here conclusion. What did you learn today? So in this lab, you have simulated three different circuits having a resistor, capacitor, and inductor. You have calculated the value of, you have seen the value of peak value of voltage, peak value of current, and then you have seen the phase difference between input and output voltage in case of resistor, inductor, and capacitor. In case of the resistor, input was input and output were in phase. In case of capacitor, output was leading than the input, and in case of inductor, the output was leading, then the input was leading, then the output. Okay, so write this conclusion in your own words here. So that's it.